In this next sequence, we're going to talk about a variety of methods that can be used to actually select the individual people, places, things, whatever it is you're interested in, that are going to be included in your sample. And a key part of this is going to be this idea of randomization. For your sample to be reasonably likely to represent the entire population, there needs to be an element of randomness introduced into the selection process. Okay, and random samples come in two varieties here. A random sample is a sample where every member of the population has an equal chance of being chosen. Right? Where a simple random sample is a slightly tighter, it's slightly more restrictive. In this scenario, it's a sample where every group of a given size has an equal chance of being chosen. All right, so let's look at a couple and some examples that kind of illustrate the difference here. So I have three scenarios here, and I want to try to classify these as being random samples, simple random samples, or possibly it could be none of the above. Okay, so what I'm going to do is first, let's assume, just for the sake of argument, let's assume that all, I've got grades here, right? 9th, 10th, 11th, and 12th grades. And let's assume that all three grades are the same size, right? Each grade has 100 students. All right, so in scenario one, I'm going to randomly select 10 students from each grade for a total of 40. All right, is this a random sample? Well, yes, it is. Right? You pick any student here, and because we're picking the same number from each category, and each grade level is the same size, yes, every student is going to have an equally likely chance of being selected. So this is I'm going to abbreviate here, random sample. Is it a simple random sample? Okay, well, it's not going to fall into that category. We're selecting 40 people, okay? And for this to be a simple random sample, every group of 40 people in the school has to be equally likely to be chosen. Now, think about, for example, a selection of 40 ninth graders. That group does not have the same probability of being selected as every other group, right? It can't be chosen at all. The probability of it being selected is 0 because we're not selecting that many people from the ninth grade, right? So no, this is not a simple random sample. Okay, that's scenario one. Let's think about scenario two. Let me clean this up here. And we'll start over again. So now we're going to select 40 students from the entire school, right? So I'm going to go to the entire school here and choose 40 people. Okay, well, in this scenario, it is a random sample. Once again, every student is equally likely to be chosen. And this one is a simple random sample. We could pick that group of 49th graders. We could pick a group of 29th graders and 12th graders. We could pick a group that has 10 from each class. Right? Every group has an equally likely chance of being selected. All right, now finally here, scenario 3. In this scenario, we select 40 students from the ninth grade, all 40 from one class, and none from the others. Okay, this is a neither situation. It is not a random sample because the chance of a ninth grader being picked is 40 out of 100, the chance of a 12th grader being picked is 0. Excuse me, the chance of a 9th grader being picked is 1 out of 100. And the chance of a 12th grader being picked is 0. So they're not the same. This is also not a simple random sample. For the same reason I talked about earlier, only now apply it to the 12th grade, for example. There's no way, if you take a group of 40 seniors, that one's ever going to be picked, because you're not picking any from this category at all. Right? So this is neither a random sample nor a simple random sample. Now, this is not going to be a big distinction for us. We're going to talk a lot about groups of a specific size, right? That's going to come up a lot when we start talking about probability and normal distributions, a lot of stuff later on. There's not going to be a major distinction, right? But I do want you to be aware of it, because if you go on and take additional statistics, research methods class, right, this is going to become an important difference. All right, so I want to talk for just a minute about non-random samples, right? Because I see confusion here sometimes with students. Just because you don't exercise control over the choice, that does not automatically make a situation random. Right? One thing I see, for example, I'll have students and they're trying to propose a research plan to collect data about people at the office they work in. And they'll say, well, I'll just survey the first 10 people to get to the office. And they try to call that a random sample. And it's not a random sample. Yes, you are not personally choosing the people to interview, but and again, go back to the definitions. Every person in that office does not necessarily have an equal chance of being chosen. For example, what if somebody's on vacation? Right? That person has a 0 probability of being chosen. What about the guy who always gets to work 15 minutes early because he rides the bus? And he doesn't get there at his work time. He gets there kind of according to the bus's schedule. So he's always showing up early. He's going to have a higher likelihood of being chosen than all of the other people who get there on time. Okay, so, and of course, none of these factors may apply. Everybody may be getting there at the same moment. And yet, it turns out everybody really does have the same probability. But you don't know. You don't know all these details, all these off-the-wall variables that might somehow come into the scenario and affect the times that people arrive, right? So that is not a random sampling situation. For something to be a random sample, you have to have a group of people, the entire population, for example, and you randomly select from that population. For example, you give everybody, think about the population of our 400 high school students. You give everybody in the population a number from 1 to 400, and then somehow pull names from a hat, maybe use a computer program to generate random numbers. Somehow you randomly select 40 numbers from 1 to 400, and those are the people who are included in your study. Okay, so what's next? Now that we've got this idea of randomness, we're going to see how we can apply this to some more specific sampling methods, right? To see some practical techniques that can be used to actually go out and select the members of a sample from a population.